Hello, welcome to you all. We are just a bit late, but it was to let time to you to come. Thank you for attending this plenary session about research and space. I am Jean-Baptiste the CEO of La Cité d'Espace in Toulouse, a science center dedicated to space and astronomy, which opened in 1997. Thanks to the initiative of Toulouse with the region, with the CNES, thanks to the CNES to found the Cité de l'Espace, Airbus also, Météo France, and the Ministry of Education and Research. It welcomed every year between 350,000 and 400,000 visitors every year. And it is the largest space science center in Europe. You will have the opportunity to visit Cité de l'Espace this evening, tonight, because the ESOF party will take place at Cité de l'Espace, and I will be very delighted to welcome you tonight in our science center. As introduction of this session, some words about the space industry in France and especially in Toulouse. It will introduce the purpose of Mr. LEGALL, President of the CNES. Historically speaking, France was the third nation in the world in November 1965, which succeeds in launching an artificial satellite in space. And still that time, France stays in the top of space nations, then contributed strongly to the foundation of ESA and still nowadays to its activities. About Toulouse. Toulouse is a place leader in Europe for space industry, and it means two things. The first one is that we host, we can say we host in Toulouse 25% of the jobs related to the space industry. So this is a question of quantity, but also a question of added value. I mean that, second point, all the sectors of this industry, of the space industry, are located in Toulouse. Of course, first of all, the CNES, French Space Agency, also labs such as ONERA. We have the pleasure to welcome a speaker from ONERA, Aeronautics and Space Lab. Industries, Airbus, TAS, and a lot of SMEs, startups, and so on. Universities, high schools, and also a science center dedicated to space. About the session now and the speakers. You have, I think, have a look on the abstract we put on the website. A few words about this. Space is an economic activity where research is very, very, very important, and I hope we will convince you about this point. All had to be invented during the last century about the space conquest, and still continue to be invented. New needs for Earth, also for us, daily uses, climate, telecom, embedded systems, and so on. Also new programs for knowledge at the time. Mission towards Mars, towards an asteroid, Hayabusa, for example, next October, towards the universe, to understand our universe. And also disruption in the industry, reuse of rockets, electrical engines for satellites, transfer of some activities from public agencies to private company, and so on and so on. So we will share that with you during this session. So to share this with you today, I welcome now Jean-Yves LEGALL. Jean-Yves LEGALL, President of CNES, Chair of the Administrative Board of GSE, the European GNSS Agency. He is also Chair of the Council of ESA and President of the International Astronautical Federation. Jean-Yves, come on the floor with me. I ask also Simonetta CHELI, Head of Strategy of ESA, the European Space Agency, to come. Have a seat, Simonetta. And then also Thérèse Donat, Deputy Director to the Technical and Programs Directorate in ONERA, a French Aeronautics and Space Lab. Thanks to you all, to you three, to be with me today to share about these matters. Mr. LEGALL, the floor will be to you now. Thanks to you for having attend to this meeting, this session. I know you will be in a hurry at the end, so maybe you will have to leave early, but it's a great pleasure to welcome you for this session. You will highlight through three things. How space is contributing to science, how space has been and still is a driver of technological innovation, and how it helps to develop our societies and economies. Mr. LEGALL, the floor is yours.
So, good afternoon. Thank you, Jean-Baptiste, for your very nice words. And I want just to say that I will not leave before the end of my presentation. In fact, I'm very pleased to be here in Toulouse because, as you know, CNES has its biggest center in Toulouse, where we have more than 1,700 people, which is more than 70% of our staff. And I used to say that Toulouse is the place when beats the art of CNES. And so what better place than Toulouse to consider all the benefits that space brings us. It is true that if space is a dream which is today shared by all humankind, and it is increasing every day, Toulouse is of course our planet, and here that dream truly takes form in all its technical and of course operational aspects. And today, what better continent than Europe to consider a science whose benefits are shared, working to gain a deeper understanding of the environment in which we live while securing its sustainable development. In fact, that is exactly the feeling I get when visiting America, Asia, Africa, or Oceania, where most of our friends and partners are making clear this need for Europe. I am therefore particularly glad to be speaking before you here today at this major and very important European Forum for Science. And I would like to address how space is contributing to science, to underline how it has been and still is a driver of technological innovation, and of course to emphasize how it's helping to develop our societies and economies. To start, I would like to say a few words about the universe, because in the field of universe sciences, space gives us a far-reaching perspective, and it gives us as well the ability to look deep at all wavelengths, free from the distorting effects of Earth's atmosphere. For example, the Planck mission, which is a very, very successful European mission, and whose principal investigators, my friend Jean-Loup Pouget, who is, as a matter of fact, also chair of the scientific programs committee of CNES. So they got the prestigious Gruber Prize and Shaw Prize, and the Gruber Prize will be given to Jean-Loup the first day of the International Astronautical Federation Congress in Vienna on the 20th of August. And so Planck takes us back to the origins of the universe. We are also probing our own origins as we explore Mars currently, which is our #1 target, working with ESA, working with NASA, in the search for clues to how life began and first appeared on Earth. You probably know the success of the Curiosity rover that has been trekking across the surface of Mars since the 6th of August 2012, almost 6 years on Mars, with its ChemCam instrument, which has been developed and which is currently operated from Toulouse. We have also InSight. Here you have a picture of InSight, which set out for Mars on the 5th of May, carrying the SCIS seismometer to probe its deep interior. And in the future, in 2020, because as you know, we can go to Mars only every 26 months. In the future, in 2020, we will have ExoMars from ESA and Mars 2020 from NASA, missions that will look for traces of ancient life on the red planet, from 2020 are all sharing the same quest. A few words about space-time, and I put on this picture Gaia. I'm going to speak about it, and a picture of a man that, of course, you recognize, who is Albert Einstein, because these are two key points of these missions. And I would like to say that the satellites are enabling us to survey space-time, for example, by verifying how far Einstein's theory of general relativity and the principle of equivalence still hold good. And so we launched 2 years ago the microscope satellite, which has been built by CNES with ONERA. And the microscope is delivering measurements that have made it the world benchmark for validating this principle. And of course, I put this picture of Gaia as well, because Gaia is a very, very impressive mission, an ESA mission, whose data are processed in Toulouse on CNES computers. And Gaia, barely 1 month ago, brought us a sensational new picture of the galaxy and the stars within it. To give you an idea of Gaia performance, it has observed 10,000 times more stars than the predecessor mission in this field, which is not so old, because the predecessor of Gaia was Hipparcos. Hipparcos is very, let us say, important for me, because working on Hipparcos was the topic of my PhD. It was a long time ago, but not so long, because I've been working on Hipparcos in the early 80s. And Gaia today provides 10,000 more stars than Hipparcos. And it became the ESA space mission that has yielded more scientific papers in a year than anything before it. It gives you an idea of the success of Gaia and this scientific history of our universe that we are tirelessly seeking in space, inspires and enriches us. Indeed, it's a fundamental need of humankind, and I would say that by fueling our dreams, it's pushing us to develop ever more sophisticated technologies and taking us each day a little closer to the stars. Now, a few words, if you allow me, about the Earth, because it's okay to speak about the universe, about the stars, but let us speak about the Earth. And closer to home, satellites are in fact a fantastic tool for studying, understanding, and monitoring our planet. That gives us a continuous, repeated, and uniform view of all regions of the globe. It measures Earth's key parameters from its deep interior to its upper atmosphere, thanks to extremely sophisticated measuring instruments operating for researchers working at the cutting edge of Earth sciences. And I would like to start to speak about oceans, because oceans are very important here in Toulouse, because I would like to take the example of satellite altimetry. Satellite altimetry is a French field of excellence that aims to measure the sea level variations that are a key indicator of global warming. Satellites are revealed a mean rise in sea level of 3.4 millimeters a year over the last 25 years as a result of melting ice sheets and warming oceans. You see on this map that all the places which are in yellow, the sea level increased, and you see that the sea level increased everywhere. And this is a map which has been made by our satellites, and we are, of course, very proud of that. And this success of satellite altimetry has been carved out here in Toulouse with more than 700 research scientists and engineers working tirelessly to refine models, instruments, and measurements to meet our growing need for deeper insight into how the oceans and our climate work. And this adventure is now set to continue as with NASA, we are readying the next generation of altimeters with the SWOT satellite that will be carrying an extremely innovative wide-swath altimetry instrument. In addition to surveying ocean topography, SWOT will also be measuring the levels of surface waters and paving the way for new applications in hydrology, with water resources being a crucial issue in the context, once again, of climate change. So, we spoke about oceans. I would like now to say a few words about atmosphere, because this is another key domain, and the CNES and the EUMETSAT developed together the YASI atmospheric sounding instrument, which, in addition to significantly improving weather forecast with a range out to a few days, YASI has advanced our knowledge of the atmosphere composition. And in the wake of this success, CNES and EUMETSAT have launched development of a new generation, so-called YASI-NG, as new generation instrument, that will assure continuity of a time series of the same parameters, stretching over more than 30 years, and this will sustain the long-term data record that's key to studying how climate is changing. And you know that climate change is very, very important in general, very, very important for France, and this is why that I would like now to make a focus on climate change. Because in response to the priority which is now being given to gauging greenhouse gases, CNES is developing two satellites. Microcarb is the big picture, and Merlin, the smallest. Microcarb is being built in partnership with the UK Space Agency to measure carbon gas with a compact and very highly precise instrument. And Merlin is a joint satellite being built by CNES and the German Space Agency, DLR, to measure atmospheric methane using a LIDAR instrument. And it will be a first that will help scientists to better quantify fluxes of this very potent greenhouse gas while identifying its sinks and sources. A few words also about technology, because technology is very, very important, and without technology, of course, no space projects. And in the field of technology, the 60s, the 70s, and the 80s saw a series of large space projects that undeniably played an amplifying role in public research and drove great technology progress. In today's fast-changing world of innovation, this contribution is more diffuse yet still very real. Large space projects are big consumers of the most advanced technologies, adapting them to the constraints of the space environment and to mission needs, and thus fueling advances and disruptive innovations in many sectors. So, it is most likely that the exploration of the solar system now taking shape will bring new technological leaps made possible by the amazing advances accomplished in many domains during the course of the last decade. And you understood that space technology, space applications have now a great impact on our societies. And I would like to continue to say a few words about that, because besides these notable contributions to scientific research and technological innovation, the significant benefits that space is bringing to economic and social development are also very, very important. Space is a source of data, enabling us to gauge crop yields in real time, measure use of natural resources on a global scale, anticipate and better understand the impact of the far-reaching transformations we are now seeing on populations, on societies, on economies. And space is, of course, a key component of our telecommunications infrastructure. Today, access to our information society is an imperious necessity, and the ability to achieve this is dictating even more radically than ever before the gap between those who are fully part of the human adventure and those who are excluded from it. And from this point of view, a point is very, very important, is this to be connected. Because being connected is a necessity, but fast broadband is a reality for only 500 million people, while there are more than 3 billion for whom simply gaining access to the internet is still a far-off prospect. Space technology, in fact, is the only way to bridge this divide and enable everyone to connect effectively everywhere on land, at sea, and now in the air. When I take the plane, there are more and more people, in general very young people, working on the internet because they are connecting during the plane. Me, I used to eat or to sleep, but young people, they are connected and they work or they play. Not only is the least developed regions of the planet and in fast developing countries with terrestrial infrastructures are still lagging behind, but also space is important to be connected in developing countries. And in France, thanks to the strong backing of President Macron and to his vibrant space sector, a project to build a new generation satellite has been engaged to bring fast broadband to 300,000 homes in our remotest regions before 2022, so it's tomorrow. This will have a notable inclusive effect and impact on the effectiveness of the public policy, as ubiquitous access to the internet is a necessity to make e-administration, e-medicine, and e-education available to everyone, everywhere in metropolitan France and French overseas territories. And this, of course, is possible because of satellites. And so I would like to say a few words about satellites. Because we have today an unprecedented wave of innovation in telecommunication satellites, the dynamism of our industry, and the future prospects for the operators who will market services. In fact, we are seeing innovation in the ground systems that connect satellites to the internet, innovation in electronic equipment and antennas to make them more flexible and enhance their performance, and innovation in the geostationary buses that power satellites and keep them on station. Satellites supported 1 gigabit per second in throughput in 2000 and 50 gigabit per second in 2010, 10 years later. Today, they are developing 500 gigabit per second and will be supplying 1,000 gigabit per second before 2025, all at a spectacularly lower cost. At the same time, the available offering is diversifying with new players conceiving and building constellations of tens and even hundreds of internet satellites operating in low Earth orbit. And this offering is capable not only of bringing fast broadband to all, but also of supporting the billions of connected objects making up the future Internet of Things, heralded as the next revolution. And in the next revolution, of course, we have the use of space applications. Because with telecommunication satellites, the space sector is therefore helping to build the plumbing to bring this new digital world within reach of everyone, everywhere. With the Galileo navigation satellites, and we will have a launch of 4 Galileo satellites the week after next week from Kourou in French Guiana. So with the Galileo navigation satellites, positioning and timing data are available everywhere for all applications. With EUMETSAT weather satellites and their YASI and YASI-NG atmospheric sounding instrument, we are further extending the range of our weather forecast. And with the Copernicus, and I'm sure that we will have something about Copernicus later on, with the Copernicus Program's environmental and scientific satellites, more and more data are improving our understanding of the environment and how it is changing. Now, let us say a few words about the future, because as you can see, whether we are accomplishing our scientific ambitions by landing Philae on the nucleus of a comet, exploring neighboring planets, confirming the most fundamental theories of science, tackling climate change to apply the Paris Agreement or the One Planet Summit organized last December, or conceiving and deploying major infrastructures for the economy and society, I think that we can say that the French, European, and international space communities are pursuing their task with dedication and determination. Of course, what gives our space community its strength is that different priorities and visions of the future may coexist or even oppose one another at a given moment. But globally, as I see it, the urgent and imperious mission that lies ahead of us is to continue working probably tirelessly to secure the future for the billions of people living on our beautiful blue planet. So you see that, in a nutshell, space is fundamental for our planet, whatever we are interested in the universe or in our planet himself. And we have in front of us a lot of developments, a lot of applications, and I am sure that all of us will be actors of this new development. Thank you.
Thank you, President. This is a confirmation that in space everything is nominal because you have just finished at 0. We have a countdown just in front of us, and it was exactly 0 when you finished. So thanks a lot to have respected this rule. Thanks a lot. So it's time for questions. We have 5-10 minutes for questions. We have 2 micros here and there. If you want to ask a question to President of CNES, that's time to you. The first question, who wants? Come to the micro, please, or someone else before you come.
Hello. I have a question. We are almost at the brink of 5G 2020. How is it going to change the satellite industry? Like, is it for the good? Or I can see many use cases coming for satellites as well, but is it also going to negatively impact the satellite business?
I think that, as you say, we have now the development of the 5G, but the 5G will be a part, of course, of future terrestrial networks, but in remote places it's very, very difficult to implement the 5G, or very, very costly. And this is why satellites are so useful to provide 5G or internet in remote locations, even in France today. But if you travel the world, in the US, there are a lot of white areas where you don't have a cell phone, and of course you don't have internet. And I am sure that internet satellites will bring internet everywhere in these remote areas, at the places where there will not be a 5G network.
Okay, so another question? Someone else who wants to ask a question? So I have a question to you, President, also. What about the Space Observatory about climate? Because you are used to say that 26 among 50 indicators for climate are collected by space satellites, May you give us some information about this observatory in which CNES have been involved?
As I said during my presentation, half of the essential climate variables can be observed only from space. These are the satellites which showed evidence of the global warming. These are the satellites, and I show the map, which showed evidence of the average increase of 3.4 millimeter per year of the average level of the oceans. And these are the satellites which can observe the emissions of greenhouse gases effect. And so with the Paris Agreement, which has been signed in 2015, now it is important to know how these emissions of carbon dioxide and methanes are evolving. And for that, we have the satellites, and the idea is to implement at worldwide level a space observatory to have all this data in common, to be able to compare data coming from US, Chinese, European satellites, and to have this kind of global observatory. In other words, what we want is a kind of free access to this data to help the different countries to fulfill the Paris Agreement, and also to know what's going on inside when a company claims that they will stop the emissions of carbon dioxide and so on. And so satellites will be very, very important, but beyond the data, we need to organize the use of this data, and this is exactly what the Space Climate Observatory will do.
Okay, and Simonetta will speak about big data just after a bit. A question, yeah? We listen to you.
Yes, good afternoon, ladies and gentlemen. I have a question to the whole image of space. So after the year 69, I think space was one of the major issues and also an inspiration for a lot of people, for a lot of children, for a lot of people in school, in university. I have the feeling that in the 70s, 80s and 90s this somehow dropped down. So a question to you, do you think that now we are in this wave, in this phase of reinvention of space, of re-encouragement, that space is a driver for young people also to be active in the scientific world and really researching about this topic?
I am sure, because there is a very big evolution in the field of space. During the last 10 years, we had a lot of decrease of the cost to access to space systems. And the origin of this decrease is definitely the digital evolution, because you have satellites which are with more and more technology, and smaller, and so cheaper and cheaper. For example, I used to say that 10 years ago, when you go to vacation, you took a camera with a lens which was 30 centimeters. Today, you take pictures with your cell phone. For the satellites, it's the same. We have a very small satellites doing almost the same what was made 10 years ago by much bigger satellite, and so more expensive. And so now, 15 years ago, there were worldwide 10 space agencies. We have 60 space agencies. We have people coming from the internet sphere, which is so-called the new space, which who invest in space. And so more and more people are invest in space. And the three key drivers are, of course, innovation, because innovation is back to space. We were in a situation where space was almost always the same. Now, innovation is definitely on the space arena. The second point is climate. This is exactly what I said, but with climate, during the last few years, we really had a new interest for space, because space is key to tackle climate change. And the third point is also exploration, because we have automatic exploration. We had Philae landing on the nucleus of the comet Churyumov-Gerasimenko. On the 3rd of October, we will have Mascot, which is French-German robot, which is now on the Japanese probe Hayabusa 2, which will land on the Ryugu asteroid. And we have also the extreme interest for human flights, probably because of the social networks, but it is true everywhere in Europe. It started with Tim Peake in the UK, continued with Simonetta Cristoforetti in Italy, Alexander Geist, who is now in orbit, and of course in France, Thomas Pesquet. And so globally, more and more people are interested in space, and I think that it is an excellent news.
And I can complete your comment with from Cité de l'Espace. Cité de l'Espace, we welcome more and more every day, more and more people coming to Cité de l'Espace to understand space, the goals of space, the interest to send satellites or human to space. So we see this increasing interest, sure, nowadays. So it's time, no more question up to now. So it's time now to welcome on the desk Simonetta CHELI. You are head of the strategy of ESA, the European Space Agency. You will highlight how technological progress and innovative approaches reshape the field of the Earth observation, more specifically the importance of big data generated, for example, by Copernicus.
Good afternoon to everybody. Yes, space, research, and planet Earth. This is the topic of the session today, and we heard how space is used for everyday life in many, many different facets, from the technology to the applications to the real scientific use and the scientific impact, and this conference is on sides. Here you see Macron, President of France, in the US recently mentioning that there is no planet B, and there is no planet B, so we have to preserve planet A, and we have to make sure that we monitor planet A, that we use satellites to do that, and to manage our resources, our energy, and to actually make sure that we preserve and we guarantee the future for the future generations. This is exactly what the European Space Agency does. We do it together with many other space agencies, with the French Space Agency CNES, but all the other 60 space agencies that were mentioned by President LEGALL. A lot of those agencies already have remote sensing satellite, and they do contribute to the preservation and the management of our planet. In Europe, I must say we're quite on the lead. We started in the 70s with the development of the meteorological missions, together with EUMETSAT today, which is the organization which manages the operations of the meteorological missions in an operational manner. We develop in ESA all the MET series and the future generation of those meteorological missions. We heard about EASI instrument, for example. We have then a series of scientific missions, the Earth Explorers, which are Earth satellites developed and devoted mainly to one specific scientific purpose. Some of those look at the gravity, some others to the magnetic field, others to the soil moisture, so different aspects of our planet and really to the scientific purpose of providing data to scientists to look at how the Earth evolves. Then there is the Copernicus Program. This is a program that it's under the leadership of the European Commission. It's an operation and not a research program. It's a variety of satellites called Sentinels, and you see how many they're here in the third middle line. And these Sentinels, some of those have already been launched, and you see in the table here, the first launches are the one in the dots, which are in black. So we have already 7 Sentinels up and running. The last one was launched end of April. They're all functioning very well. They do different things. They have different instruments on board. Some have a radar instrument, some an optical one, some an altimetry on board. And we plan to launch many more in the coming years. And this puts really Europe in the forefront, I would say, not only of the big data revolution in terms of volumes of data which are managed. Look at this. This is the daily production, the 15 terabytes mentioned here, of products which are available and which are produced every day by Copernicus satellites, but also the dissemination of the Sentinel products to users. A very important principle was mentioned is the fact that these data from all the ESA missions, but including the Copernicus European missions, are free and open. So they're accessible to all scientists all over the world and to all users all over the world. And this is really, I would say, a game changer in the sense that volumes of data which are managed today with the Sentinel series are 10 times or even more the ratio of what was managed in the past with research satellites. Typically, ESA launched in the 90s, ERS 1 and 2, ENVISAT then, and a few other satellites like the Explorers I mentioned, but today we are looking really at a change of dimension in terms of the data policy, but also in terms of having a long-term continuity of sustainable data, systematic, of the same type, which are available to users, even to people who want to make money out of it, commercial users or value-added companies, and so you really have an economic sector and not just a scientific sector that's built around that. Here you see the number of registered users. In order to access the data for the Sentinels, you do register and you have a website interface, and you do have numbers which are increasing every month, and as you say, in a very steadily manner, and you have figures around that. In order to facilitate this, they've been also set up what we call Copernicus, let's say, Access Hub, which are basically putting in place national infrastructure to complement the one offered by ESA, or infrastructure that is devoted to access such data on a national basis by national users in a fast way and in a dedicated way. And this has also been set up for a number of international partners, typically Geoscience Australia, and entities in the US like NASA, NOAA, and USGS. We have 6 Copernicus services up and running. Those are managed by the European Commission, and one of those you'll hear more about it. It's one on ocean, and you'll hear from Mercator, our colleagues here in Toulouse, what they do with the Copernicus data in the marine field. Here you have just the overview of satellites. Those in green are the ones that have been launched, and those in blue, the ones we plan to launch in the coming years. And of course, looking at the future, we have to look beyond the 2020 25 area. We are looking already at the next multi-annual financial framework of the Commission to look at the extension of the current satellite, at the evolution of the satellite, and looking at new user requirements coming typically from, for example, the implementation of the COP agreement, which needs dedicated satellites in the future, typically CO2-related missions or missions that look more carefully at the land surface agriculture in order to support challenges which are societal challenges. And here you see the overview of what was presented in 2015 by the UN, United Nations, all the societal challenges, and many of those can be supported by space. I want here now to go very briefly into a number of examples of scientific results of our missions. And here you see the geoid coming from Goce. Goce ended its lifetime in 2013, but it gave the most ever precise view of the Earth. And this has an impact also for those scientists who study the gravity, those who look at ocean circulation, so everybody who works on the climate change field. SMOS, soil moisture, ocean salinity. You see here in 2017 in June, one of the driest seasons in Europe recently. In the north, you see the areas of Holland which are the ones underwater. In the south, you see the red parts which are the ones which were more dry at the time. And here you see a land cover map. This is a map which is a map on Africa. Interesting to see that with satellites, you can see the differentiation of the crop. You can look at the different type of biodiversity. You look at vegetation coverage. You look at the evolution and the variability between summer and winter. And you can do many things like from subsidy monitoring in terms of European policies monitoring, but you can also do food security activities, and that what, for example, ESA does a lot with the FAO and with other entities working in the field, which is not ours. We're a research organization, we're a technology organization, but we work very closely with developing aid agencies and also, for example, with the World Bank in this field. Here you have an example of Patagonia, the glacier decline there, monitored by Cryosat. Cryosat is one of the missions of ESA which has an altimetry on board. So with this mission, you don't look only at the extension of the ice, but what you look is at the sea ice, so the one which is underneath the sea level, and you do that thanks to an altimetry. And this is very important because basically you can have plans and models of the evolution of the ice extent over various regions, which are remote regions, often like Arctica or Antarctica. There was a very recently publication on Nature in June, exactly based on data from Cryosat, integrating data from this mission from 2010 to 2017. Here you have an example of monitoring rice yields. This is done with Sentinel-1 data, and you see that in these areas of Vietnam, some areas you have a double rice culture over the year. These are the green parts, and in some areas which are mountainous area, the red dots there, you have only one rice crop per year. So very interesting for agriculture, for food security. Another interesting aspect and feature of what satellites can do to help us manage our Earth is the field of natural disasters. Together with CNES and actually with Jean-Yves LEGALL, we started the Charter on Disasters many years ago at Unispace 2 in '99. We're very proud of it, I must say, both CNES and ESA, because this is an endeavor of now 17 space agencies which provide in-kind data from the Earth observation mission whenever there is a natural disaster happening in the world, which means either flooding, disasters, earthquakes, typically the volcano eruption recently. We're working these days on the Japan events of the last few days. And this is done also through a technique called interferometry, the one on earthquake, which allows monitoring of very millimetric movements of the terrain. Here you have the hurricane monitoring. This is another feature that satellites can offer. Not only you get the temperature and you get to apparently minus 80 degrees at the top of the hurricane whenever this is happening. This is Harvey, and you can also see the direction of the winds, so the direction that the hurricane is going to go towards, and you can certainly predict hurricane better and also monitor the way they evolve during the time, and this is essential. Air pollution, it was mentioned by President LEGALL. 5P, it's the satellite that we launched in the Sentinel series last October. It was just recently ending its commissioning phase. It's an extraordinary satellite because it gives a lot of information about methane and NO2 concentration. And you see here a map recently generated by KNMI, which is basically the Dutch agency working on the satellites, which provided, by the way, also an in-kind instrument on board the satellite called Tropomi. And from these maps, you see the concentration of NO2, and you certainly support decision makers for monitoring the state of the Earth. You have also a report, a yearly report is produced by the European Environment Agency. The last one was done in 2017, but here there are figures coming from the 2016 one, which mention 467,000 estimated premature death due to air pollution causes. So you see the direct relation of research in the field of space, the research that is done in Europe, but not only, with the support of data from satellites. Greenhouse gases, it was also mentioned, and this is the evolution of basically the carbon dioxide from 2005 to 2015, if I'm not mistaken, and you see an increase of 9% overall, so the trend is quite scary, I would say, and we certainly need to monitor with additional tools and additional satellites in the future, this type of trends. Cryosat, the ice melting, the shifting grounding lines are essential to see the evolution of the ice and the way it's melting, and this is another example of that. The sea level rise, 3.4 millimeters was just mentioned by the previous presentation, and there are estimates that the sea level could rise up to 1.3 meters in the next 80 years. These are data integrated through our program in ESA called Climate Change Initiative, which is monitoring climate variables on the based on the UNFCCC convention, integrating data from different sources, including various satellites, nationals, European, and American ones. Thank you very much. I hope I've given you an overview and a quick snapshot of what we can do with satellite in support the research and in support the management of our planet, and I'm available for questions if you have any.
So thank you, Simonetta, for this presentation. Do you have some question? Probably great. Come on, yeah, come to the micro. Prepare to go to Mr.
Hello. Thank you very much for the very interesting presentation. I'm amazed to see what's possible. I still have one small question, maybe. What's your vision on space debris? We're putting more and more satellites in low Earth orbit, but...
Yeah, space debris is certainly an issue. Just to give you a figure, there were 220 only Earth observation satellites launched between 2007 and 2017. Their expected launches in the coming years estimated are only in Earth observation satellite, more than 500 satellites. So not only this is the field, but certainly there's an issue of space debris. There is a huge effort at technical and legal political level to tackle this issue. At the political level, through the United Nations, through COPUOS, where there are discussions on, let's say, provisions and agreements on the way to contain, even with liability clauses, with responsibility by the country who actually launches the satellite to contain that. We have also technical provisions in the sense that today there is a regulation, for example, in Europe, any satellite we launch after 2020, we have a provision to guarantee that there is on board enough fuel to do a controlled re-entry, not an uncontrolled one, which means this would certainly limit the debris issue. There is also a technical collaboration among space agencies, which is very important. It's organized in ESA through ESOC, which is our center of operation in Germany. We have a collaboration with ground station, tracking stations all over the world in a network with the US, with the Russians, and whenever there is an issue of debris, we monitor that. So both at technical, political level and legal level, there are quite some efforts because debris is not a minor issue for sure.
Thank you, Jean-Yves, no? Thérèse, no? Okay. Okay, another question. We listen to you. Yeah. Okay. Another question, yes, sorry.
Thank you very much. I was wondering if the Cryosat satellite measures the shrinking of the Arctic and Antarctic ice shields by measuring the Earth gravity field, just as the GOES satellite did and the GRACE satellite does right now?
No, the principle of the cryosat satellite is to have the altimetry on board, which looks at the thickness. So what we do to look at the evolution of the ice, we normally combine data which come from another satellite called Sentinel-1, which has a radar on board and looks at the shrinking of the ice, so the evolution of the ice extent. We combine that with the altimetry data from the cryosat satellite, which look more at the thickness. And all this information integrated together gives you very good trends on the ice extent and the evolution of the ice.
And then I have another question concerning long-term data, because I know that those long-term data time series, they're very rare. In case of GRACE, they had a gap now this winter for 1.5 years, basically, where they didn't measure the water fluxes in the planet Earth. And so I was wondering, what are you doing to tackle this issue?
The issue of long data preservation is an essential one. In fact, space is having a big evolution, as it was said before, not only in innovation, but also in the way we try now to preserve our data. We try to make sure archives of data are maintained. And what we do, initially, for example, in ESA, when you used to fund the missions, you were only funding the archiving of the data for a few years. Now we have a program called Long-Term Data Preservation, which is looking exactly at trying to guarantee preservation for long duration of time of all data, not just Earth observation, but also the ones coming from the space station and from the scientific mission. And this is an essential core activity of ESA. In fact, it's funded in the basics activity of the agency, because we consider that a very strategic element of granting data for long term. And this is relatively new trend, I would say, with such a strategic importance given to long-term data preservation in general in space and, of course, in environment as well.
Okay, yeah. Richard, one question. The last question, then we'll have the last speaker.
Thank you. The US scientific community, many cities and states have been reacting to Mr. Trump's decision about climate change, and also against some position concerning the role of science for the future of humanity. I would like to have your opinion about, are some projects, space projects, I know ESA and CNES also are working with American, with NASA and other groups, are some of these projects endangered by this president's decision? Thank you.
I can reply for ESA, maybe if Jean-Yves wants to reply for CNES. What I can say is that at the level of the scientific collaboration, the technical collaboration which we have with various US entities, USGS, NOAA, and NASA, nothing major has changed so far. First of all, because when you have an international collaboration in place, it's the last one to be put in danger. Secondly, because our collaboration today with NASA at the level of ESA is really a technical and a scientific one. On one side, we do CalVal activities, so when we launch a mission, we validate the mission with data coming from airborne campaigns from NASA, which has much more resources than Europe in terms of flying planes over remote regions. We do have data exchange. We don't do a lot of hardware development, apart on a satellite called JSON-CS, Sentinel-6, and there we do collaborate on hardware with NASA and NOAA right now, and this has not changed since Trump. Of course, we're not particularly happy of the political context, but what we try and have as an approach, being a technical and a research agency, is to continue the way we have a very good and strong collaboration with our US partners and to help them in the way that the project we have ongoing will continue. And for the moment, I can say, at least in the collaboration we have on Earth Sciences with NASA, we haven't changed anything. We also try to be a lead in the political arena on Europe, so that we hope that things might change also in the US. We also support very much the community, which is the scientific community in the US. So not just in Europe, but the fact of having a free and open data policy with people producing papers on scientific journals today between the European and the US community, that helps a lot. And I think that you cannot totally stop from one day to the other.
No, I share the same view. We have long-standing cooperation with the US in the field of oceanography, which is directly linked to tackling climate change and also in the Mars exploration. And we heard a number of, let us say, statements, but we are continuing our cooperation, and I think that it will continue.
Okay, thanks a lot. Thanks a lot to you. So I will ask now Thérèse Donat, Deputy Director to the Technical and Programs Directorate in ONERA, French Aeronautics and Space Lab, to go to the lectern. You will highlight new paradigms in space industry, new design constraints in order to protect space environment, and in the reverse, new opportunities to protect Earth environment. So it's to you now.
Thank you for your introduction. You hear me? Yes? So the idea of my presentation is to show how the context of space research has evolved those last years, and I will try to illustrate by some results. Of course, I will not be exhaustive. Of course, I will not go in details because I am not an expert of all those results I will present. But I want to show that space research is well attached to the time. Yesterday, and it's a global presentation, and I will speak about launches and spacecraft. Yesterday, space was largely driven by defense and strategic issues, as well as science, as we have seen before. But defense and strategic issues were important, and space was part of the arms race between nations. This remains true because current space nations continue their research for defense, of course, and emerging ones want to also perform their own researches to acquire this capability of being in space, of launching in space, which is very, very recognized on the international scene. But now this issue is far from being unique. Now business issues and environmental issues are very in front of the scene of space research. Why? Economical issues and the fact to access to low-cost space as well for launches or spacecraft, and considering that they are not an objective but only a mean to get data, to transmit data, is now in the front of the scene. And space research is aimed to reduce costs also. Environmental issue, and I think it's more in view with our session today, environmental issue is transforming also space research, adding new constraints to preserve space environment, and providing new opportunities to protect Earth's environment. So, as time is short, I will illustrate some result of research by the two last bullets, which is space research to protect space environment and space research to protect Earth's environment. Space research to protect space environment. Space activities are no more exempted of dealing with environmental issues. This is extremely challenging because design margin for existing and operational launcher or spacecraft are very limited. You cannot change a little thing to take into account environmental issues or environmental constraints. So I will illustrate some results and some results which of course interest ONERA concerning green propulsion for satellites and space debris consciousness. There were a question just before. I will add my little contribution to that. Green propulsion for satellites. I will launch a film, but I will explain you to what it corresponds. Up to recently, orbit rising from the transfer orbit given by the launcher up to the final operational orbit, which may be the geostationary orbit, was realized using chemical propulsion. Chemical propulsion was based on hydrazine derivatives. So, you know that hydrazine derivatives are quoted on the REACH list and may be forbidden soon. So we have to propose research, and every space operators have to propose new solutions to cope with that. One solution which is well known, I will come after to that, is electrical propulsion, which is used nowadays and is working. But chemical propulsion may be also proposed, changing globally the old-fashioned one. The idea of ONERA in this domain is to propose the hybrid propulsion, which is not a new idea, because hybrid propulsion is existing for a long time. The definition of the hybrid propulsion is to have simultaneously a liquid oxidizer in the engine and a solid propellant staying in the combustion chamber, and the fact of putting them together ignites the engine. The problem of hybrid propulsion is the fact that engine performance is not constant, and it's not interesting for operational use. So ONERA recently, together with a European consortium led by Airbus in the H2020 project, called eProgeo, designed a new combustion chamber which is mechanically shifted in order to keep the combustion area constant and so on the performance of the engine. What is interesting for you today is that those it's not paper study, it's a real experiment which has been performed 30 kilometers from here in Foga, and whose duration has been 3 minutes long, which is quite a record. And we are very proud of these results. For electrical propulsion, which is another way of propulsion and rising of the satellite up to the final orbit, ONERA is also working on this subject on new generation propulsion with, for example, an engine for which we could get rid of the neutralizer of ions. And then we could have a lower cost engine and a much reliable propulsion system. The fact this is not operational, since we have to understand more deeply the physical phenomena. We do not understand completely the physical phenomena, so there is very much theoretical research on that, and we have to obtain a high performance, a high power engine to be interesting for operational satellites. Another way could be to equip nano satellites with those kind of electrical propulsion, as those nano or very small satellites are not propulsed from now. I come back if I can to space research to protect space environment, saying a word on space debris consciousness. We had a question a few minutes ago. Oh. On space debris, and I want to say some words on that. First satellite has been launched in 1957, and since that time, today, there is 19,000 space objects larger than 10 centimeters, more than 700,000 objects larger than 1 centimeter and millions of them below 1 centimeter. Among them, 900 are active. As CNES says, if we do not do something on space debris, probably, maybe in 100 years, space may not be usable anymore. Why? What is feared by a specialist is the Kessler syndrome. We can explain like that. One satellite colliding with another is generating thousands of objects. Those objects become sources of new collision, exploding new other satellites, and so on. And you could open a collisional chain that would increase exponentially the number of debris. Another term, which is important and very new, is the interest of the Internet company for mega constellations and the fact they could launch several thousand of satellites in the next years. So the number of objects, active or inactive, could increase a lot in the next years. So to work on space debris, to my opinion, there are three ways. Preventing collisions, the first one, of course. CNES, ESOF is doing that every day because they have in charge operational satellites. They can predict the collisions and propose avoidance maneuvers to avoid, of course, this collision. The problem is not proposing new prediction collision methods. The problem is to get the operational picture. We are not autonomous in Europe on the picture giving us the 19,000 objects which are necessary to propose this prediction of collision. These data are coming from the US, and Europe is not autonomous for that. We have some systems in Europe working as the graph system or some optical sensors which are capable of giving some information, but they have not been designed to cope with such a problem. So there are many researches on that subject. Here you have an illustration of a radar breadboard which has been developed in ONERA to detect under ESA contract space debris down to 5 centimeters large. You can also decrease impact of collision, giving some redundancy to more exposed subsystems, partially shielding satellite. Why not inventing space swarms to replace one monolithic satellite by many satellites in order to be able to replace one of them if one has been damaged? And of course, you can act on the environment itself, decreasing the number of objects, saying, as ESA answers just a few minutes ago, asking to the future satellite to re-entry after the operational use. The problem is for inactive satellite or satellite who do not have propulsion to re-entry. Many research is done in this domain using robotic arms in the idea of using, of course, we are not doing it today, in the idea of removing the satellite using a robotic arm. Why not carried by a space tug? Increasing the area of the satellite to accelerate its re-entry by using the residual drag to which it is exposed, and so on. These are space debris domain is a major subject of researches in many thematics. Now, if we are going to space research to protect Earth's environment. I will be very short because the preceding briefings has really well illustrated what is done in this domain in Europe. What I will say, it's only what research is done in this domain. For greenhouse gases measurement, we have speak about Merlin and microcarb. ONERA is working, and people in general are working on new generation LIDAR, whose source can be adjusted to simultaneously measure the all greenhouse gases like methane, water vapor, and carbon dioxide. We also work on miniaturized spectroimaging sensors, possibly carried by small satellites, to have constellation to survey the climate. I think nobody before me has spoken about the biomass mission, which is an ESA mission, which will be launched in 2021. It's a very important mission for climate and the understanding of the carbon cycle, and which is stored within the forest. The idea of this mission is to measure to reduce the uncertainty of carbon dioxide storage within the biomass, which is actually of 40% up to 20%. For that, the biomass mission will carry a P-band synthetic aperture radar with an antenna of 12 meters, which will be capable to measure both forest density and forest height in order to get to the biomass and then to the amount of carbon. Why research is working within that? Research has been and for example, airborne campaigns have been made to predict the performance of such mission, comparing the equivalent of a P-band radar used on the biomass mission with terrestrial acquired data. So this illustration will conclude my briefing. I hope I have shown that space research is well connected to the societal needs and also economical issues that we are encountering today. I hope I also show that research is not only high-terreal but very low-terreal. Sometimes we have to understand the physics in order to propose operational and well-working instrument. Thank you.
Okay, thank you. Some questions, to go to the micros, to ask a question to Ms. Donat. Yes, we'll listen to you first, and then Madame, then you.
Okay.
Okay, fine.
All right.
And then.
Okay, thanks for the presentation. I have a question to some project regarding a factory in space. Is there some research going on? Because some of the biggest effort, of course, is to bring the technology up beyond the atmosphere, of course. And is there some research going on, or do you know of some research in Europe or globally that tackles this issue? Thanks.
Oh yes, there are probably the aim of getting. Of course, the aim of getting a factory in space is an interesting dream, I will say, because the launcher is a complex part of the access to space. I think this dream needs a lot of research in terms of control, guidance and control, in terms of materials and structures. Probably I do not know all research which are done in Europe or even in France on that subject, but probably we are working on all the bricks which are necessary for that. I don't think there is a current program on that, but we are working on those bricks. And when a program will begin, or would begin, probably we have work to put all these things together, but bricks, I think, are working on.
Okay, 2 questions there, yeah?
With respect to the space debris, my question is, what is the distribution in height? Does it accumulate at a certain height, or is it evenly distributed all over the place?
No. The distribution of debris is not uniform, of course. You have a major ring of debris in low Earth orbit at 800 kilometers. Why 800 kilometers? Because there has been a big breakup after the Chinese collision in 2000. I have last decade, and there are debris in the MEO ring at the navigation orbit in MEO, and there are debris in the GEO ring, which are the main used orbits, of course. So you have not a uniform ring.
Is this a problem for aviation, or not really?
Oh no, I don't think it's a problem for aviation, because
it's much higher, right?
Yes.
Okay. Aviation goes until 10 kilometers around, and space usually, we'll say, begins at 100 kilometers, but in fact, really at 300 or 400, for example, for the ISS, the International Space Station. So it's much more high. Yes. But come tonight at Cité l'Espace, we have a hands-on about the debris, and we show the distribution and so on of these debris. And that's interesting to understand, because it's quite impressive, but space is quite large also, so it's a problem, but it's not such a problem. It's both.
Yeah, my question is for the two of us, and also for President LEGALL, but somebody may answer. Yes. The three of you have alluded to the Paris Agreement in 2015, and I was wondering, of course you do not invent your tools and projects just suddenly like that, how much this agreement had been actually prepared, anticipated in terms of programs, and how much it has triggered a new strategy or program?
In terms of preparation, I would say not so much. We always knew that satellite missions were able to contribute to environment monitoring, and we had already started since 2008, since COP15, a program in space called Climate Change Initiative, which was based on the climate variables. So we had prepared, but we didn't know what the Paris Agreement was going to be. So, but we had prepared with a dedicated program using space data, integrating those space data from different sources into models for the climatologists, for the scientists, to support the variables and the monitoring of the variables. After the COP agreement, I think what is important is that there is a strong impulsion, not only at political level, but at technical level, also in the field of space. And now you've seen that President LEGALL has mentioned Merlin, has mentioned microcab as national or missions in collaboration with partners. The same is in Europe. So in Europe, we're looking at what should be the future of Copernicus, the future of the Sentinels, and one of the missions which is envisaged is a CO2 mission, to be prepared on time to match some of the requirements of the Paris Agreement. So we're looking also in terms of timing of when to launch it, and also in terms of user requirements to look and feed into the requirements which are put together not only by the European policies but the Paris Agreement. So I think there's been quite a great impact on also the design of future space missions, which we can say today both at national level and at European level.
Okay, so it's time now to conclude this session with a flash presentation about one of the concrete uses of space that our speakers mentioned, the program Copernicus, more specifically the Copernicus monitoring service for environment and the GeoBlue Planet initiative presented by Pierre-Yves Le Traon from Mercator Ocean. So we listen to you, Pierre-Yves. Okay. 3 minutes flash presentation,
okay.
180 seconds.
Yes. So good afternoon. My name is Pierre-Yves Le Traon. I'm the scientific director of Mercator Ocean, the Global Ocean Forecasting Center, which is located here in Toulouse. So my presentation deals with the ocean, but also with satellites. As was mentioned in the panel discussion, satellites play a key role to observe, understand, and forecast the ocean. I have 3 main short messages in this flash presentation. First, observing and forecasting the ocean is imperative, and the need has never been so pressing. The ocean play a fundamental role on the Earth's climate, but they also provide food, energy, and many economic activities depend on the ocean. But our oceans are a threat. They are impacted by climate change, warming of the ocean, sea level rise, loss of oxygen, acidification. And they are also subject to strong pressure due to pollution or overfishing. So we need a much better and comprehensive monitoring of all oceans to better protect them, but also to better manage them and in a sustainable way. So on this is recognized at the highest political level. It was mentioned previously, we have this United Nations Sustainable Development Goal, one of them being dedicated to the ocean. We have the IPCC on this special report on the ocean and cryosphere, and more recently the G7 with the Future of the Ocean initiative. Second message is the Copernicus Marine Service in Europe is today providing a unique capability to monitor and forecast the global ocean on European seas. This is the world-leading ocean monitoring service, which is part of the European Copernicus Program, which is by itself a really outstanding achievement in Europe. And the Copernicus Marine Service is implemented by Mercator Ocean. It has been operational since 2015. This is a science-based and integrated approach to monitor and forecast the ocean. So we are using observation from satellite, from the Sentinel missions, from the Copernicus program, but also other important missions such as the JSON altimeter satellites, together with in-situ measurement from ship, from profiling floats, from buoys, together with state-of-the-art numerical model to describe and forecast the ocean. We today have more than 13,000 users who depend on the service we provide for key activities such as maritime transport, marine safety, development of marine renewable energy, aquaculture, fishery management, and of course climate monitoring. Last point is on international cooperation. So observing and forecasting the ocean on the longer term is extremely highly challenging and can only be achieved through international cooperation. GEO is an intergovernmental organization dealing with Earth observation. Mercator Ocean last week organized the 4th GeoBlue Planet Symposium as a satellite event of ESOF. We had more than 300 participants from more than 40 nations, and from the USA, South Africa, Australia, Bangladesh. And the theme of the symposium was Our Future is Blue, linking ocean and coastal information with societal needs. So this led to a highly stimulating discussion on how the new monitoring capabilities that are developed in Europe, for instance, through Copernicus, can help us to better address both societal and blue growth challenges, but also to better inform citizens on the essential need to better protect and better manage the ocean. Thank you.
Thanks a lot. Thanks a lot to you. So, such as the French Mousquetaire, 4 minutes for 3 minutes, but that's okay, that's fine. We are with the French Mousquetaire. Thanks a lot to you. Thanks to the speakers for your availability. And thanks to you. I hope it was a productive session to you. And see you tonight.